Trigonometry class. This is our lesson on section 2.4. We're going to be doing something called solving right triangles. We should already know how to do many of the things that we're going to be doing in this lesson here, but we've never been necessarily asked to solve a right triangle, and I'll show you what that entails in this lesson. And then after we solve right triangles, we're going to be doing something called angles of elevation or angles of depression. So let's go ahead and get started. All right, so this is what solving right triangles mean. To solve a triangle means to find the measure of all the angles and sides of the triangle. In a right triangle, in solving it, we already know one angle measurement. Angle C is always going to be our right angle. And then we are going to also find what angles B and A are if neither of those are given to us. And then also, all side measurements, so side A, B, and C in this triangle, we will solve for those if they are unknown. So, it's important to sketch this triangle right here. And like I've told you in class, I'm going to get my pen out, that this triangle is representative of all the right triangles that you're going to be drawing for this section here. So for angle A, your angle A, your side A is always going to be opposite of that angle. And same thing goes with B. Your angle B, the side opposite of that is side B. And then for angle C, that is always your right angle, which opposite of that is always your hypotenuse. So make sure you label the and draw or sketch your right triangles appropriately in this manner right here that I just showed you. So let's look at an example. Okay, so on this example, what you're normally given is just solve right triangle ABC if this right here is the information that you'll be given. Okay, and normally you're not given this drawing right here. You are going to sketch that if you need to. You don't have to. But my advice is go ahead and sketch this triangle out and label the sides A, B, and C appropriately, like I just showed you in the previous slide. And then determine what all you need to figure out. So in this triangle, we are given that B is equal to 28 degrees and 40 minutes, and that's your angle B. And then side A is the 25.3 centimeters. So solving this right triangle, what we have to figure out is, I'm just going to write it up here real quick, is angle A, what is that equal? And then we need to figure out side B and side C. Okay, so we're going to figure out all three of those unknown measurements that we do not have. That's why we call them unknown. All right, so let's go ahead and get started on this one. What I say to start with, if you already have one angle given to you up in the given information, because this is a right triangle, these two angles, A and B, are always complementary, meaning they add up to 90 degrees. So take the angle that you are given and solve for your other angle. So in this case, we're going to figure out what A is equal to. And A is equal to 90 degrees minus your 28 degrees and 40 minutes. Do that calculation, and if it's in degrees and minutes, then I want your answer also in degrees and minutes, not in decimal degrees. Okay, so let's put this in degrees and minutes, just like our value for angle B is in. All right, so A is equal to, if you do this calculation correctly, you should get 61 degrees and 20 minutes. Okay, so now we have both of our angle measurements. We have A, we have B, and we also know C, of course. Now with all of our sine, cosine, tangent, trig functions that we have been studying, we are going to figure out what our side measurements are of our triangle. So for side, let's just start with B. For side B, let's start with our angle that we're actually given to us. So angle B, side B is opposite of our angle B, and we are given the adjacent side. Okay, so we're asked to solve for the opposite, and we are given the adjacent. So think about what trig function that is, opposite and adjacent. Well, there's two trig functions. There's tangent and there's cotangent. I'd go with tangent since that's on your calculator. So write tangent of your given angle, so 28 degrees and 40 minutes. And then set that equal to your ratio, which is opposite over adjacent, which in this case is B over our given measurement for A, 25.3. Okay, now that you have this equation, solve for your unknown. Tangent of 28 degrees and 40 minutes is just a number. So to figure out what B is equal to, we're going to multiply both sides by 25.3. Like that. Sorry for the messiness, but that's how it goes. And this cancels out here. And we're left with B is equal to what's on this side of our equation. So plug that into your calculator. Plug the 25.3 times tangent of 28 degrees and 40 minutes. Plug that into your calculator. And what you should get is, let me see here, what did I get? 13.8 is what I got. And that's going to be in centimeters. Okay, so now let's solve for C. I think I have another slide. Good. So this is my same triangle on this side. Now let's solve for C. C is our hypotenuse, and go with the information that you're given always. We're given this angle B, and we have this side measurement A. Okay, according to this side and this side, our angle measurement B, this side is our adjacent still, and then C is our hypotenuse. So adjacent and hypotenuse. Think about what trig function has your adjacent and hypotenuse in it. And that would be cosine or secant. Like I said before, with a tangent or cotangent, I would go with cosine because that's a function on your calculator. So cosine of your angle B, which is 28 degrees and 40 minutes, that is equal to your adjacent over hypotenuse, so A over C. Your A is 25.3, and C is what we're trying to figure out. Okay, now to solve for C, we got to get C out of the denominator. So multiply both sides by C. We get rid of that. Now we have C times cosine of this angle equals 25.3. Well, now divide both sides by the cosine of 28 degrees and 40 minutes. And when we do that, we get C is equal to the 25.3 divided by the cosine of 28 degrees and 40 minutes. And plug this right here into your calculator, and we should get approximately 28.8 centimeters. And then we're done. Once we find the all the unknown information of our triangle, you're done. So we found what our angle A was from the beginning. We already found B, and now we found C. So all the angles are known and all the sides are known now. We're done in solving this right triangle. Let's do another one. Okay, so in this slide, I kind of want to tell you before we go on to the next example is that there's so many different ways of solving right triangles. And they all produce the correct answer, but to maintain accuracy, always use the given information that you start out with. So I'll go back to this previous slide to show you. We could have, in this one right here, since we found what B is equal to in the previous slide, we could have used that fact that we figured out what B is to help us in figuring out what C is. We could have used the Pythagorean theorem, let's say, because we have A, we have B, we've got two sides. The third side we could have found with the Pythagorean theorem. But that wouldn't have been as accurate as finding it this way like we did already. So to maintain accuracy, always use the information that you are given to find other unknown information in your triangle. All right, here's another example. In this one, we are given a right triangle that has two sides given. Previous one had a side and an angle given. So we need to solve this one in a different way than we did the previous one. So if you're given two sides to start with, the third side can easily be found with the Pythagorean theorem. So let's start out using that. Pythagorean theorem is this right here, a squared plus b squared equals c squared. Plug in your values for a and b. So 44, oh, not 44 squared, 44.25 squared. B is 55.87. Square that. Now to figure out what c is, we need to take the square root of both sides of this. So c is equal to, well, approximately equal to 71.27. And that's in centimeters. Now, our previous section, we looked at finding angle measurements by using our inverse sine, cosine, tangent functions. And that's how we're going to figure out these angle measurements for A and B in our figure here. We need to figure out what is B and what is A down here. You can start with either one. And like I said in the previous information here, always use the given information, not what we have solved for and approximated. So to find, let's just start with angle A. Angle A, to find it, let's figure out what trig function we need to use. So angle A, we have our opposite and our adjacent information given to us. So that means we're going to be using our tangent function. So tangent of A is equal to our opposite over adjacent, so the 44.25 over the 55.87. Okay, now this isn't going to be your angle measurement. What I kind of need y'all to do is not approximate this number just yet. To get a very accurate angle measurement, at this point, to find what A is, which is your angle, you need to take the inverse tangent of both sides. So inverse trig functions find angles, and the regular trig functions, they do not. Okay? They help you in finding side measurements the majority of the time. All right, so inverse tangent, since that's what we're using, tangent here, of our 44.25 over 55.87. Now plug this into your calculator and your output will be an angle measurement. And this is going to be in decimal degrees, so you don't have to worry about putting this in degrees, minutes, seconds, but you can if you want. I'm not going to stop you. So this ended up for me being 38.38 degrees. Like I said, you can put this in degrees, in minutes, seconds if you want to. I went ahead and did that. It's going to be 38 degrees and 23 minutes approximately. All right, now that you have this angle measurement, just like the previous one, whenever you have one angle measurement, use that angle to find the other one. So A and B are always complementary. They add up to 90 degrees. So take your angle measurement here and subtract it from 90 degrees. And you will get 51.62 degrees, or in degrees and minutes, you get 51 degrees, sorry, not point, degrees, that's a terrible degrees, there we go, degrees and 37 minutes. There you go. That is solving a right triangle. We found angle B, angle A, and side C. All the information that was missing from our triangle. We're done. So here are the steps I would suggest you do for solving all right triangles. First, draw a sketch and label it with the given information. And then label the quantity to be found with a variable. So if you're looking for side A and side B, label it that, A and B. And then use your sketch to write an equation relating the given quantities to the variables. So just like I did on one of the slides, it was something like tangent of A is equal to another over another number, and you found what A is equal to from that equation. And then once you do that, write your equations, then solve the equations and check that your answers make sense. So checking that your answers make sense is like for these angles right here, one way to check to see if all of your angles make sense is add them all up. Does it equal 180 or something really, really close to 180? Then you're probably correct. And so that's one way of checking your answers on that. All right, so let's look at an application problem. Here is what we're going to be applying in our application problem right here. These are about angles of elevation or depression. The angle of elevation from point X to point Y above X is an acute angle formed by ray XY. So here we have our horizon, and our angle of elevation is like when our eyes are looking up. And that angle that our eyes are pointing upwards, or our angle our head is moved upwards, that is called our angle of elevation. Now, the angle of depression, we have our horizontal here, and we are looking down. So that is our angle of depression. Now let's look at some application. Okay, so this application problem says, hold on, there I am. The angle of depression from the top of a tree to a point on the ground, 15.5 meters from the base of the tree, is 60.4 degrees. Find the height of the tree. So if this over here, I don't know if y'all can see that. So if this is our angle of depression right here, this horizontal right here is parallel to this horizontal right here. So if this angle of depression is 60.4 and these two lines are parallel, remember we have two parallel lines with a transversal going through it, which is AB. That means we have some congruencies of our angles going on here. So angle that is labeled our angle of depression, 60.4 degrees, is going to be the same for our angle B in this triangle. Oops. Let me get that out. Our angle B right here is going to be congruent. It's also going to be 60.4 degrees. So we have this right triangle that is being created. We know this angle, and we know this side measurement right here, and we want to find what is B. Let's do that. So we have side measurements that is adjacent to the angle that we are given, and then opposite. So opposite and adjacent, that is tangent function that we are going to be using. The tangent of our angle, which is 60.4 degrees, is equal to our opposite over adjacent. So B over 15.5. Okay, now solve for B. Multiply both sides by that 15.5 and plug this right here into your calculator and give me an approximation for what B is equal to. And what my calculator gets is 27.3. And that's going to be in meters, since your measurement over here is given in meters. So 27.3 meters is how tall the tree is going to be. And that is it on that problem. Let's do another application problem. Okay, so in this application problem, it says find the angle of depression from the top of a 97-foot building to the base of a building across the street located 42 feet away. Okay, so what we're going to do here is first, let's just sketch a little drawing here, what exactly we're doing. So draw a building. Here's my building. It is 97 feet tall. 97. And then, let's see. We have an angle of depression from this that goes all the way down to, it's 42 feet to the base of another building. So right here, that's a right angle. We're trying to find out what is this angle of depression right here. Okay, so from the previous exercise that we did, this angle of depression and this angle right here are congruent to each other. So if we find this angle, then we know the angle of depression. I'm going to go ahead and label this A, B, just label my vertices of my triangle. Let's see. Okay, so now we have a good drawing, a good diagram of what it is we're trying to find. We're trying to figure out what this angle is. So to figure out what this angle is, just go from your given information. So we're looking for the angle, and the information that we're given is the angle the side opposite of this is 97, so this is our opposite, and then we have our adjacent. So opposite and adjacent, that's our tangent function again. So write it out. Tangent of our angle we're trying to find, which is B as I labeled, and that's equal to our opposite over adjacent, so 97 over 42. Now that we have that, solve for B. So when we're solving for an angle, we use our inverse functions, our inverse trig functions. So B is equal to tangent inverse of our ratio 97 over 42. And that gives us an approximation of 67 degrees. I'm just going to round to the nearest degree. And 67 degrees is our answer. That is going to be our angle of depression. So we're done on that one. Oh, and that means we are also done for this video. Like I've said before, let me know if you didn't understand anything from this lesson in class the next time I see you, and we will be working on some more problems. So I'll see y'all later. Goodbye, everybody.